As the largest city within the country's most populous state, Los Angeles has a rich history of meeting infrastructure challenges with progressive, environmentally sound solutions. When it comes to the city's water supply, its virtual lifeblood, Mayor Eric Garcetti has committed to reducing dependence on imported water. One component of a multi-pronged strategy to reduce water imports includes local supply augmentation through water recycling. The city's largest treatment facility, the Hyperion Water Reclamation Plant, represents a critical building block in any water recycling approach. With an average flow of 260 million gallons per day, it can provide a significant drought-proof source of water. The city is embarking on a forward-thinking MBR pilot facility to assess the suitability of advanced processes for the treatment and reclamation of Hyperion flows. Ultimately, this would entail the conversion of the existing secondary treatment facilities to advanced purification systems that can produce a high-quality water suitable for a variety of reuse applications. The test facility will, first, determine the capabilities and effectiveness of advanced purification systems. Second, demonstrate their performance to the regulatory community. And finally, provide a basis for the design of a future plant conversion. The MBR pilot facility will use the effluent from primary sedimentation as its source of water. The first step in the advanced purification process will be fine screening. The screening is to protect downstream mechanical equipment by the removal of any materials greater than 2 millimeters in size that might be carried over from primary sedimentation. Once screened, the flow will enter the membrane bioreactor, also known as the MBR. The MBR provides a secondary level of treatment and has two principal components: the biological reactor and the membrane separation system. The reactor is a multi-stage biological treatment process that facilitates the removal of organic matter, nutrients, and solids. Within the reactor, there are aerobic and anoxic zones to maximize treatment effectiveness. The treated liquid from the reactor is fed into the MBR's membrane system with microscopic pores to separate water from the biomass solids. Solids are returned to the biological reactor, and the clarified liquid is conveyed for further purification. 3 membrane separation systems provided by different suppliers will be comparatively tested. The next step is reverse osmosis, also known as RO. In this process, the liquid is forced by pressure through membranes with very small openings. This process removes dissolved salts, organics, and pathogens that may remain after the MBR process. The final step in the process involves disinfection for pathogen destruction before reuse. This involves irradiation by ultraviolet light in combination with the application of a strong chemical oxidant. This approach is referred to as UV-AOP, UV for ultraviolet, and AOP for advanced oxidation processes. Within the test facility, there will be a number of chemicals used to clean membranes, condition the treated water, and provide disinfection. Chemical feed and storage systems will be located in a single location with truck access for routine deliveries. The MBR pilot facility will demonstrate the effectiveness of advanced treatment systems to produce a high-quality, reliable supply of purified, recycled water for all customers. It's a major step toward achieving the mayor's goals of reducing the demand for imported water and 100% recycling of all wastewater in Los Angeles by 2035, consistent with LA's Green New Deal. Conserving our water and sourcing it locally.